We have seen convergence in probability and some examples on convergence in probability. Now let us go for next convergence, and that convergence is convergence in rth mean. Convergence in rth mean. काय म्हणते बघा, let xn and xn equal to 1 with the sequence of random variables. आपण sequence define केले sequence of random variables such that फक्त काय पाहिजे बघा, expected value of modulus value of x is to r exists less than or equal to infinity, meaning that the modulus of the expected value of modulus value of x is to r exist होते less than infinity, in fact less than infinity, less than infinity. We say that the sequence xn converges in rth mean. काम तो है ये exist होता सकता है. We say that the sequence xn converges to rth mean in rth mean to random variable x if कभी condition क्या हुआ, expected value of modulus value of xn minus x raised to r, modulus value of xn minus x raised to r tends to 0 as n tends to infinity. कारण वह xn converges to x in rth mean कसं म्हणजे expected value of modulus value of xn minus x raised to r tends to 0 as n tends to infinity. It is denoted by xn converges to x in rth. याला rth मतलब म्हणजेच rth mean. xn converges to x in rth mean. Priority काय तो xn converges to x in p दिसतो आपण. इथे xn converges to x in rth mean. Now we have a particular case. If r instead of r, if we take 2, so convergence in second mean म्हणतो आपण याला. second mean म्हणजे त्याला म्हणतो आपण quadratic mean. दुसरं काम त्याला quadratic mean. Quadratic mean. So let xn n greater than equal to 1 with the sequence of random variables such that expected value of modulus value of x is to 2 आता. Quadratic म्हणजे 2 येते, power 2. So expected value of modulus value of x is to 2 exists, so less than infinity, and we say that the sequence xn converges to in म्हणजे आपण quadratic mean. Quadratic mean to random variable x if expected value of xn minus x याचा काय घेणार आपण आजच्या ठिकाणी 2. expected value of xn minus x is to 2 converges to 0 as n tends to infinity, tends to 0 as n tends to infinity, and it is noted as this xn converges to x याला असं कधी लिहिलं असेल quadratic mean, converges to quadratic mean, किंवा कधी असे लिहिलं जातं xn converges to x in 2, r ची व्हॅल्यू नंतर आपण 2 घालतो. So the second definition is convergence in quadratic mean. Second mean means quadratic mean. So in that xn n greater than equal to 1 with the sequence of random variables with that expected value of modulus value of x is to 2 exists less than infinity. We say that the sequence xn converges in quadratic mean to random variable x if and only if expected value of modulus value of xn minus x is to 2 tends to 0 as n tends to infinity. And it is denoted as xn converges to x in quadratic mean or xn converges to x in 2. So these are the two definitions of convergence in quadratic mean and convergence in rth mean. Now let us find out some examples on this convergence in quadratic mean or convergence in mean. One such example is let us have some remarks. The first remark is the sequence xn n greater than equal to 1. The sequence xn n greater than equal to 1 such that expected value of modulus value of xn 2 raised to 2 exists less than infinity, exists less than infinity, and is said to be, this is said, then the sequence section is said to be convergence in quadratic mean, convergence in quadratic mean to a constant. This section converges to sequence section converges to C in quadratic mean if Canada, but that expected value, sorry, not quadratic, expected value, modulus value xn minus c raised to converges to 0 as n tends to infinity. We write like this: xn converges to c in quadratic mean. Xn converges to c in quadratic mean. Then we also know that now modulus value of xn minus x square is same as absolute I is same as xn minus x raised to 2. कारण का मॉड्यूलस का स्क्वायर असल्यामुळे मॉड्यूलस घेतला का मॉड्यूलस नाही घेतला का काय प्रॉब्लेम नाही. Therefore, the quadratic mean is also known as mean square method, also known as mean square convergence. Mean square convergence. This is also known as mean square convergence. Now let us study few examples on this convergence in mean. Now one such example is let xn n greater than equal to 1 be the sequence of random variables. The sequence of random variables be the sequence of random variables x. Okay, sequence of random variables x such that write that xn is equal to 1 is equal to 1 minus 1 by and write that xn is equal to 0 is equal to 1 by then show that the sequence xn does not converge in quadratic mean to 0. The sequence xn does not converges in quadratic mean does not converges in quadratic mean to 0. 0 म्हणजे आपल्याला दाखवायचं दॅट इज सोल्युशन. काय दाखवायचं आपल्याला एक्सपेक्टेड व्हॅल्यू ऑफ मॉड्यूलस व्हॅल्यू xn minus converges to does not converges to. So xn minus 0 raised to 2 does not converges to 0 as n tends to infinity. Does not converges to 0 as n tends to infinity. So we have expectation करायचं. We have x is equal to हे आपण x is equal to 0 and x is equal to 1. आपला x काय तर मला x काय का 0 ची व्हॅल्यू 1 by n आणि ही व्हॅल्यू 1 minus 1 by n. 1 minus 1 by r. Now expected value of, now consider expected value of, consider expected value of modulus value of xn minus 0 raised to 2. xn minus 0 raised to 2. Consider केलं. आता हे कन्सिडर केलं की आपल्याला काय मिळणार आहे बघा. हे म्हणजे काय आलं, expectation of this is equal to this is equal to expectation of xn square. Expectation of xn square. And क्या प्रॉब्लम है, xn square. This is equal to summation xn square pxn. xn square pxn. This is equal to xn square pxn. So this is equal to, so this is xn pxn. So 0 into kind of 0 into 1 by n plus 1 into 1 minus 1 by n. This is equal to, this is 0. 1 into म्हणजे काय ना 1 minus 1 by n. 1 minus 1 by n. What is this? This is expected value of xn minus 0 plus expected value of xn square. Now, as n tends to infinity, 1 minus 1 by n tends to 1. कारण हे जाणार कशाला 0 ला, 1 राहणार 0. That means that is xn does not converges to 0, does not converge 0 in quadratic for this particular product distribution. Xn does not converges to 0 in quadratic mean. Okay. Now, the next example. Let xn n greater than or equal to 1 with the sequence of random variables x such that, आता याला बदललं बघा, x is equal to xn is equal to 0 ची प्रोबॅबिलिटी, xn is equal to 1 ची प्रोबॅबिलिटी आपण चेंज. So xn is equal to 0 is equal to 1 minus 1 by n, and xn is equal to 1 is 1 by r. Xn is equal to n is 1 by n. So show that xn converges, now xn converges to 0 in quadratic mean, into किंवा in QL कसे लिहू शकतो. आपल्याला काय पाहिजे आता, आपल्याला दाखवायचं काय, एक्सपेक्टेड व्हॅल्यू ऑफ मॉड्युलस व्हॅल्यू ऑफ xn minus 0 raised to 2 tends to 0 as n tends to infinity. हे आपल्याला दाखवायचं. त्यासाठी काय करूया आपण, पहिल्यांदा प्रॉडक्ट डिस्ट्रीब्यूशन द्या xn ची व्हॅल्यू 0, xn ची व्हॅल्यू 1. pxn आपण घेऊन टाकूया, pxn is equal to काय, xn is equal to 0 ची व्हॅल्यू काय 1 minus 1 by n, and xn ची व्हॅल्यू झाली 1 by n. Okay, now consider expected value of modulus value of xn minus 0 raised to 2 is equal to expected value of modulus value of xn square. This is equal to expected value of xn square, and this is equal to summation xn square pxn. आता xn square pxn घेतली काय होणार बघा, मला सांगा. xn स्क्वेअर म्हणजे काय ना 0 चा स्क्वेअर, 0 स्क्वेअर into 1 minus 1 by n plus 1 square into 1 by n. हे 0 झालं 0 होणार, हे राहणार काय फक्त 1 by n. As n tends to infinity, 1 by n tends to 0, म्हणजेच काय expected value of modulus value of xn minus 0 raised to 2 converges to 0 in quadratic mean. किंवा xn tends to 0 as n tends to infinity, म्हणजेच काय रे, xn converges to x in converges to 0 in quadratic mean. So priority change केले क्या होते, xn converges to 0 in quadratic mean होते, xn converges to 0 in quadratic mean. Now we have seen the convergence in quadratic mean, convergence in R3. Now let us find out what is convergence in distribution. Convergence in distribution. Convergence in distribution. Similarly, let x and n equal 1 be the sequence of random variables say x, and fnx be the distribution function of xn. आता distribution function घेतली त्याच्यात xn fnx. So n greater than equal to 0. Let x be a random variable. तिथं आता काय पाहिजे random variable x पाहिजे. x be a random variable with the distribution function fx. आता काय पाहिजे ते variable पाहिजे x त्याचं distribution function काय पाहिजे fx. We say that xn converges in distribution to random variable x if काय होगा limit n tends to infinity fnx is equal to fx for all values of x at which fx is continuous. काय होते हैं fnx is equal to fx limiting case मध्ये limit n tends to infinity fnx is equal to fx किंवा fnx tends to fx and n tends to infinity असं आपण लिहू. कशासाठी पाहिजे at x for every value for all x at which fx is continuous. It is also known as convergence in log किंवा काय म्हणतोय weakly convergence. Weakly convergence काय weakly convergence and it is noted by आपल्याला म्हणतो xn converges to x in log एक तर येत येतो or xn converges to x in distribution d लिखो xn converges to d लिखो क्या है xn converges to x in log xn converges to x in it is also called as weakly convergence. Now let us find out some examples for this convergence. For example क्या होगा xn क्या पाहिजे xn चं distribution function fnx पाहिजे आणि तिथे एक रँडम व्हेरिएबल x पाहिजे त्याचं डिस्ट्रिब्युशन फंक्शन fx पाहिजे असं पाहिजे काय पाहिजे लिमिट n टेंड्स टू इन्फिनिटी fnx इज इक्वल टू काय पाहिजे fx. हे थोडक्यात काय ॲज n टेंड्स टू इन्फिनिटी fnx कशाला जाते fx डिस्ट्रिब्युशन फंक्शनचं नेचर हे इथं जसं आहे fnx आहे तसं दिसतं एखाद्या पर्टिक्युलर डिस्ट्रिब्युशनचं होतं fx होतं. ओके इंडिपेंडेंट ऑफ n. आणि असं होत असेल तर काय म्हणतो आपण xn कॉन्व्हर्जेस टू x इन लॉग किंवा xn कॉन्व्हर्जेस टू x इन डिस्ट्रिब्युशन किंवा वीकली कॉन्वर्जेस xn कॉन्वर्जेस टू x वीकली. Okay. First example is let xn be the sequence of random variables with that provided that xn is equal to 1 plus 1 by n. एकच व्हॅल्यू घेते xn is equal to काय येते 1 plus 1 by n is equal to 1 with provided 1 म्हणजे व्हॅल्यू एकच असणार आहे बाकी सगळं 0 असणार आहे. Show that xn convergence in distribution to a random variable. Xn converges in distribution to a random variable. Now let us have we know that our xn is equal to किती value आपला xn is equal to 1 plus 1 by n. xn ची व्हॅल्यू काय 1 plus 1 by n आणि pxn काय आहे सगळं मला pxn is equal to किती आहे 1 आहे 0 अदरवाइज त्यामुळे काय प्रश्न नाही. आपला fnx काय आला सांगा मला fnx is equal to fnx काय आला fnx is equal to इथे काय होणार आहे इथे 0 असणार आहे कधी याच्या खाली असेल त्या म्हणजे x less than 1 x less than 1 1 plus 1 by n x less than 1 0 if x is less than 1 plus 1 by as soon as it becomes 1 so this becomes 1 x is greater than or equal to 1 plus 1 by बाकी सगळ्या व्हॅल्यूसाठी नेक्स्ट काय असणार आहे x greater than equal to less than असणार आहे x is less than 1 plus 1 by आणि 1 बनवणार x greater than equal to 1 plus 1 by x less than आता काय करतो तुम्ही हा नाउ ह्यालाच लिमिट आहे लिमिट n tends to infinity fnx काय होणार fnx is equal to काय होणार आता 0 होणार as n tends to infinity so 1 plus 1 by n tends to 0 1 by n tends to 0 आणि x is less काय राहतं x is less than 1 आणि 1 as x is greater than equal to 1 so x greater than equal to 1 x less than 1 साठी काय होणार आहे 0 आणि x greater than equal to 1 साठी काय होणार आहे x so fnx मिळाला 0 x less than 1 1 as limit in this infinity. हे काय झालं डिस्ट्रीब्युशन फंक्शन झालं. म्हणजेच काय झालं बघा आता त्याला 1 म्हणजे आपण आता कन्सिडर घेऊया आपण एक आता दुसरं डिस्ट्रीब्युशन घेऊया का प्लॉट दॅट x इज इक्वल टू 1 आता आपण घेतलं प्लॉट दॅट x इज इक्वल टू 1 हे डिस्ट्रीब्युशन घेतलं x इज इक्वल टू 1 त्याची प्लॉट काय घेतली 1 त्याची प्लॉट 1 घेतली. आता x ची व्हॅल्यू 1 झाली त्याचं डिस्ट्रीब्युशन फंक्शन काय होणार f(x) ची व्हॅल्यू काय होणार आहे x इज इक्वल टू 1 ची व्हॅल्यू 1 म्हणजे काय 0 when x is less than 1 and 1 when x is greater than equal to 1. fx हे प्लॉट डिस्ट्रीब्युशन आहे हे डिस्ट्रीब्युशन फंक्शन आहे आपल्याला डिस्ट्रीब्युशन फंक्शन मिळालं आणि ह्याला आपण दोन म्हणतात याला दोन म्हणतो 1 to 1 काय होतं बघा लिमिटेड टेन्स टू इन्फिनिटी लिमिटेड टेन्स टू fx is equal to 0 1 x less than 1 x greater than equal to 1 हे fx असंच आहे x less than 1 x greater than equal to 1 म्हणजे काय लिमिट f tends to infinity f(x) tends to किंवा equal to in fact equal to f of x. Therefore we say that xn converges to x in log or xn converges to x in distribution or xn converges to x in weakly converges to x. xn converges to x weakly. Okay. Now, the next exponential derivative is independent and distribution of variables with common median f(x) is equal to 1 by theta. You raise that f(x) is less than theta. So, if you want to develop a constant that you raise theta. It's not theta uniform distribution. Continuous distribution of the range equal to theta. Okay, what about theta? Another different derivative xn, आता आपण शिकतो derivative xn different is equal to maximum of x is equal to xn is equal to क्या आता आपण आपल्याला xn converges to x in log आता xn converges to x in log आपल्याला काय करायचं हां आपल्याला काय करायचं आपल्याला माहिती आहे x करून त्याला आपण म्हणूया तुम्हाला करून आता दिला तर आता डिस्ट्रीब्युशन फंक्शन आहे तुम्हाला तुम्हाला f(x) मिळते x minus a by b minus a आपल्याला माहिती आहे त्याला आपण x इक्वल टू 0 आहे मग x आणि b इक्वल टू त्यामुळे x by theta fx आता सीधे what fx now consider from there आता आपण या x bar maximum of x1 x2 x. आता हे x काय म्हणजे आपल्याला काय करायला पाहिजे क्युमुलेटिव्ह डिफरन्स काढायला पाहिजे आता क्युमुलेटिव्ह सी हियर क्युमुलेटिव्ह डिस्ट्रीब्युशन सॉरी क्युमुलेटिव्ह डिस्ट्रीब्युशन क्युमुलेटिव्ह डिस्ट्रीब्युशन सी हियर ऑफ x आपण जर क्युमुलेटिव्ह करतो f xn x इज इक्वल टू या आपल्याला काय maximum काय असते maximum साठी काय प्लॉट दॅट xn म्हणजे बाहेर मी तुम्हाला प्लॉट दॅट xn इक्वल टू सम ऑफ x आता maximum जर x ची व्हॅल्यू असेल तर सगळे पाहिजे प्लॉट दॅट x1 इक्वल टू x into प्लॉट दॅट x2 इक्वल टू x सो ऑन प्लॉट दॅट xn इक्वल टू x दिस इज तुम्हाला आपल्याला ऍक्च्युअली ऑल्सो स्कूल दॅट पुन्हा देतात आपल्याला प्लॉट दॅट x1 इक्वल टू x प्लॉट दॅट x2 इक्वल टू x from प्लॉट दॅट x इक्वल टू x सगळे पॅटर्न इक्वल टू म्हणजे काय f of x वर x आणि हे काय असते fx काय fx आहे fx so this is the f of x and x fx and x is equal to fx raised to n आता काय fx आता काय fx is equal to x by theta हमारा क्या है x पहला x by theta raised to n x by theta fx and x by theta raised to n x by theta raised to n now हमारे fx मतलब क्या है fx and x बना हुआ fx आता fx झाला अपना लेकिन क्या बोलते हैं fx divided by theta x divided by theta raised to n. X divided by theta raised to n. So we can write it like this. So now we can write it equal to 0 x divided by theta raised to n is equal to x divided by x is greater than 0. And the part of the one of that x greater than theta. X greater than 1 x greater than theta. So I get theta is greater than 2 theta. Okay. Now the reference is equal to now limit limit n tends to infinity. Reference time मात्रा इतना ज़्यादा and n tends to infinity. Let's back it down to 11. Back it down to 10. And n tends to infinity. X was equals to 0. Itu berapa? Ini 0 lah. X greater 0. Okay. Atau n So this is fx is equal to now let x be a random variable such that right now x is equal to theta is equal to 1 and 0 then we get the experience function of the distribution function that becomes the part x is equal to 0 and after x 0 x greater than theta. So x greater than theta and the one part x greater than equal to theta x greater than equal to theta. Otherwise, here calculate this 0 is equal to zero. Theta is equal to 1. So fx is equal to 0. X is less than x is less than and it is equal to 1. X is as well because theta is equal to 1. So therefore next one is that 0 is 0. Okay. So we can say that the next one is to fx in distribution. We can say that. Fx limit fx is equal to f(x) on the itself converges to x not on the distribution or simply converges on. Now let us write some theorems on statements only. Theorems on convergence in plurality. असा पहिला आहे हा बघा एक नंबरचा असा आहे if xn converges to x in probability xn converges to x in probability and g dot is any continuous function and g dot is any continuous function continuous pi function any continuous function then we can write then gxn converges to gx in probability. gxn कुठलेही फंक्शन असू दे gxn एनी कंटिन्युअस फंक्शन gxn converges to gx xn converges to x असेल then gxn converges to gx म्हणजेच काय दोन नंबर लिहा आपण म्हणजे असं आपण म्हणूया आपण xn converges to x in priority then आपण लिहिलं 2xn converges to 2x 2xn converges to 2x एनी फंक्शन कुठलंही फंक्शन डिफाइन केलं तर आपल्याला काय लिहिता येतं आपला कुठलंही फंक्शन डिफाइन केलं तर आपल्याला 2xn gxn converges to gx in probability प्रोबॅबिलिटी ही प्रो आहे जी 2xn converges to 2x in probability okay next result number 2 is result number 2 or 3 we can say 3 if xn converges to x in probability and say another sequence yn converges to y in probability then xn converges to x in probability yn converges to y in probability then we can say that xn plus yn for the other means yn converges to x plus y in probability किंवा xn minus yn converges to x minus y in probability किंवा xn into yn converges to x into y in probability also xn divided by yn converges to divided by probability xn divided by yn converges in probability to x divided by y. However, if xn converges to x in probability and yn converges to y in probability, then xn plus yn converges to x plus y in probability. Xn minus yn converges to x minus y in probability. Xn into yn converges to x into y in probability, and xn divided by yn converges to x divided by y in probability. Converges to x divided by y in probability. Another theorem number 3 is already get chart. If xn converges to c in probability, xn converges to c in probability. Constant, any constant, xn converges to c in probability. Then xn square converges to c square in probability. त्याचसोबत इथे पण म्हणतो आपण if xn converges to a in probability and yn converges to b in probability and xn plus yn converges to a plus b in probability xn minus yn converges to a minus b in probability xn into yn converges to x into y a into b to in probability xn divided by yn converges to x divided by a by b in probability. So constant is xn equal a and constant of this b ला तर हे पण इथे बघा xn plus yn a plus b ला converge होते xn into y a into b ला होते xn divided by n a divided by b ला converge होते. हा आणखी एक आहे. These are the some theorems on convergence in distribution. We can see some examples, more examples in the notes. This much we have to study about the convergence in priority, convergence in quadratic mean, convergence in arc mean, and the convergence in distribution. Now, in the next lecture, we are going for weak law of large numbers.